Hi everyone. Hi all. Warm welcome to our event from Byte Academy. So myself Indira, a full stack web instructor at Byte Academy. So today's event is linked list in Python. So let's understand and implement the linked list data structure using Python. Thanks all for joining. We'll begin soon. So, hi, thanks all for joining. Welcome once again. So this is an event from Byte Academy. So myself Indira, a full stack web instructor at Byte Academy. So after the event and for later communication and all, you can join us in our free community on Discord. Okay. So the Discord app, you can install it in your laptop or mobile phone. And this link will be sharing in the description as well as in the chat. Okay. So once you download Discord, you can click on this link to join our community. Nestria server on Discord. Okay, so there we can continue the discussion, and I'll be sharing the material of this webinar in the particular channel. So Python resource channel in the Nestria Discord web server. I'll be sharing the material of this webinar also. So you can get it from there. So let's begin linked list in Python. So we are going to understand what is a linked list data structure in Python, and we are going to implement it using Python language. Okay. So what are we going to learn today? We'll be seeing what is a data structure, and linked list is a data structure. So what is a linked list? So what's the use of linked list? Okay. What are the real-time applications of linked list? After that, we'll be going to hands-on. Okay. We'll be understanding the logic, how to create a linked list using Python language. Okay, so we'll be seeing how to add one element into a linked list from in a particular position, how to delete an element from a linked list from a particular position, how to create the linked list, how to delete the linked list. The operations on linked list we are going to implement using Python. So let's see what's the data structure. So every programming language has data structures. So you can say like a variable. Okay, you wanted to store something in a variable. So data structures. So basically, you can say like it's a place to store your data. So we will learn variables when you learn any programming language. X equal to 10, X is a variable. Okay, you're storing the value 10 in X. So it'll be something like, let me share my whiteboard. Hope the whiteboard is visible for all of you. So let's say X is a variable. So if you're writing something like this, X is equal to 10, what is happening? So there's a memory location. There is a storage location inside the computer. That location is named as X, and your variable, the value of your variable is stored in this location, and the value is 10. Okay, so let's say this location will have a memory address. So if you try to print that memory address in any programming language, you'll get some hexadecimal value. So for simplicity, let's say this address of this location is 2000. Okay, so this is a variable. So this very simple thing. So more than that, so you can store only one value here. If you want to store multiple values, let's say 1, 2, 3, 4, 5, a set of values, you'll start using data structures. Okay, so this is a memory location. So let's say if you want to store the values 1, 2, 3, 4, 5, you need to use something more complicated than a simple variable like this. So you will allocate, you will have a location. So let's say this variable, this set of values, let's say it is called as values. So you will create a data structure for this. So internally it will look like this. Okay, this location can be continuous or non-continuous memory location. So we'll come to that. It will be stored like this, 1, 2, 3, 4, 5. So in this case, okay, this will have an address. This value it is storing in address. Let's 100. So if to store the integer 1, if you need 2 bytes, okay, if you need 2 bytes to store the integer, so this location will be 102. This location's address will be 104. This 106, 108, like that. So this is what is a data structure. Not this. There are many data structures more complex than this also. So what is a data structure basically? It's a storage. It's a data storage. You need to store your data in an organized way. Okay. So if something like this, let's say you might have heard about array or list in Python. So let's say this is a list in Python. So you can access this list using values of 0. So it will have index. Index always start from 0, 0, 1, 2, 3, 4. So the indexes are 0 to 4. So some memory location data storage where you wanted to store your data in an organized way, and there will be restrictions to access. There will be method to access the data and update the data. So that is what is a data structure. So we are going to learn a data structure called linked list today. Let's go back to the PPT. So what's a data structure? A data structure is a storage that is used to store and organize data, or you can say like is a storage that is used to store organized data. So it's a way of arranging data on a computer so that it can be accessed and updated efficiently. So there'll be ways to access and update the data stored in a data structure. You're storing your data in an organized way. So there are different ways. There are different type of memory locations. There are different types of data structures to store your data, like arrays, lists, stacks, queue, linked list. Okay, so one of them is linked list. So let's say data structures, you can divide it into linear data structures and non-linear data structures. So what is linear data structure? Linear in the sense sequential, right? So data structures in which data elements are arranged sequentially or linearly where each element is attached to its next adjacent elements, like this next element and previous element. So one element will be connected to one element like that. Linear data structure. So this is called as linear data structure. Data elements are arranged or stored sequentially. So you can say, yeah. So arranged sequentially, linear data structures. Non-linear data structures where data elements are not placed sequentially or linearly. Okay, they're called non-linear data structures. So let's say in a non-linear data structures, one element can be connected to multiple elements. It is not stored in a linear way. Something like this. Let's say you're storing. So we have seen if you're storing the data like this in the memory. So this is what? This is linear. The values 1 to 5 you're storing in the memory like this. This is what? This is you're storing it in sequential way. So linear. So let's say you're storing it something like this. Yeah. 1, 2, 3, 4, 5. So this memory address is 100. This is not something nearby 100 or this can be 2000. But these two are connected. This can be 3000. This can be something else. 200. The memory location's address. This is 400. Okay. And is the data arranged sequentially? No. Right. It is stored here and there, like non-sequentially, non-linearly. So that is what is linear data structures, linear and non-linear data structures. This is a pictorial representation of that classification of data structures. So data structures, there's some data. There is a data storage where you can store your data in an organized way and access and update the data in an efficient manner. So that is that kind of storage, storing data, that way of storing data and accessing and updating data in a particular manner. So you can store and update and access in different ways. So we use different data structures for that. So classification, linear data structures, non-linear data structures. Okay. So linear data structures, you can divide again to static. Okay. You cannot add dynamically how many ever elements in that. So array dynamic data structures, you can keep on adding it. You can dynamically increase the size of that data structure. Like you can dynamically add how much ever data you want, whenever you want. Okay, there's no like something you can add only 5 elements. That is what is static. Something else you can keep on adding how many elements you want. So that is what is, you can dynamically increase the size of the data structures. Those kind of data structures are called as dynamic data structures. So inside the data structures, linear, non-linear. So inside the linear, dynamic, there comes our linked list. Okay, so there are many other dynamic linear data structures, stack, queue, linked list. So one important data structure in any programming language which you should know is linked list. So non-linear data structures, tree, graph. So I have shown that pictorial representation. So a tree will look like a tree. So this itself is a tree structure, right? So you have stored it something here, something here. This is connected to these two. This is connected to these two. So non-linear. So non-linear data structures examples are tree and graph. So we are going to see linked list here today. So let's see what's a linked list, how data is stored in a linked list, how you access the data, how do you create a linked list. Okay, so you can think of linked list as a chain. Okay, so it can be conceptualized as a chain. So it's a concrete data structure consisting of a sequence of nodes. So okay, one element can be called as a node in a data structure. Sorry, node in a linked list. You can have multiple nodes. You can keep on adding nodes in a linked list. So linked list itself different A classification is the different types of linked list are there: single linked list, doubly linked list, singly linked list, doubly linked list, circular linked list, etc. So we are not going to all those things. We are going to learn the basic singly linked list. So each node, so linked list will have nodes as elements. Okay. So each node stores an element and a link to the next node so that it is connected. So the first links or the first node. Okay. So the first node or the variable which is pointing to the first node of the linked list is called as head or head node. The first node of a linked list is called as a head. So the first link in the chain is called as head node. So let's see a visualization, then only you'll understand. So this is how a linked list look like. So let's say this is a memory location. Okay, this is a memory location. This is the first node of the linked list. So linked list, we are seeing the basic linked list only here, singly linked list. Okay, so this is one node of the linked list. This is the memory address. Okay, one node of a linked list has two fields, one which is storing the data. So you can say like this is a data field and this is a next field. So we are storing 10 in this data field, and what we are storing here, we are storing the address of the next node. So what is the address of the next node? This. So you will store that address here. That means what? These two links are connected. So this is pointing to this node. Okay, and this is the second node. Data field is 15. Next field has the address of the next node. Okay, you're storing. That means this is pointing to this node. So the address, let's say 5000 is stored here. That means it is pointing, this field is referring to the memory location which has the address 5000. So this is the node. So it is pointing to the next node. And data field 5, this next field stores the address of the next node. So which is this? If you store the address here, that means what? This is pointing to the next node. So this, let's say this is the last node. Okay, this is the last node in the linked list, the last element in the linked list. So data field is 20. Next, you don't have any next node. This is the last node. So you'll store null or none. In Python, we can say none. You don't store anything. It is null, right? It is none. It is nil or what? So there is no address stored because there is no next node. So this is the last node. So how do you identify a last node in a linked list? The next field of that node will be none or null. And you will always have a variable called head. Okay. So in this linked list, we have 1, 2, 3, 4 nodes. Okay. The data you're storing is 10, 15, 5, and 20. Okay. This is connected to, so after 10, which is the next element? 15, next 5, next 20. So these elements are connected and sequentially connected. So the linked list is a linear data structure. Okay, you can access, if you traverse through the linked list, first 10, next 15, next 5, next 20, right? So it is a linear data structure, which is dynamic also. Why it is called as dynamic? You can add a new node here. How do you add a new node here at the end? Okay, you'll create the memory location. You'll store a data value there, let's say 25. Okay, you'll make the next field null, none. So there will be a memory address for that node. That address, if you store here, what happened? This next is pointing to that new node added. Okay, so if you do that, a new node is added. So you can add it, you can increase the size of a linked list like that. So it is called as dynamic. So linked list is a data structure, is a linear data structure, which is dynamic. So head, so you need this head to traverse through the linked list. So you always store the address of this first node. So this node is called as the head of the linked list. Okay, so you always store the address of the first node in a variable. You will always name it as head. Okay, so which stores the address of the first node. So anything is storing the address of the first node. What does that mean? It is pointing here. Okay. So if you know this head, only the head, that means the address of the first node, you can traverse through the linked list. So the logic will be something like, okay, you know the head. So this is head dot data will be 10, head dot next will be this pointing to this. So you basically set some temporary variable, you will set it here. Okay, and you move that. So that temporary variable is equal to this dot next. Then you move this pointer to here. You access the data from here, and you move the pointer like temp is equal to temp is currently pointing here. Then temp equal to temp next. Then it is moved here. Then you access the data. It is moved here, and you will access this data until. How do you go till the end of the linked list? You check if the next field is none. That means that is the last node. Then you don't need to move that again. Okay, so this is the basic visualization of a linked list. I mean, singly linked list. So before going to the implementation of a linked list in Python, okay, we'll see the basic logic in our whiteboard again. So let's see what's the use of a linked list. So how it is, what's the different or okay. So there are situations when the allocation of memory to store the data cannot be in a continuous block of memory. Sometimes, let's say the continuous block of memory is not available. So you have a set of values to store. Okay, you need to store that and store it in sequential way only. That means the element should be connected to, you should be able to know right after this is the next element. After that, the next element is which one. So element should be connected. Okay, so you need to get that sequential order, but you don't have continuous memory locations to store those values. So that time you can use if that time you can use linked list. Okay, so if we are using linked list, we can store connected elements in non-continuous memory locations and dynamically add nodes even though it's not in continuous location. So as per the availability, you can do that. So let's see how is that. So let's say it's something like this. Let's say this is the memory location we have. Okay, so I wanted to store 1, 2, 3, 1, 2, and 3. So if memory location, continuous memory location is available, so let's say this memory location is 100, this is 102, this is 104. Continuous memory location is available, then you can store it like this, 1, 2, and 3. Easy, done. Okay. If that is not available, what will we do? Okay. So let's say here one is a location, a memory location is available to store one integer. Here there is something, here there is available memory, here there is available memory or storage. Okay. And everything else, this all are full, this all are already have some data. Okay. So that case, if you go for some other data structures, you need continuous memory location. But if you use linked list, you don't need continuous memory location. So what you will do, let's say you will store 1 here. Okay. Let's say the memory location's address is 100. You will store 2 here. Memory location's address is 200. Let's say you will store 3 here. The memory location's address is 300. So how do you connect these elements? How do you know like after 1 is 2, after 2 is 3? You store it in a linked list. How do you store it in a linked list? So we know linked list consists of nodes. So your first node, okay, memory address is 100. So you have some memory over here, memory location over here. So you store your first node over there in 100. Store the data value. So every node, 2 fields, the data field and the next field, right? The next field. So 100, okay. And you store 2 here. You store 3 here. The next node, the available memory location, you store 3 here. And this address is 200. This location's address is 300. Okay. You connect. How do you connect? You store 200 here. That means the next field, you store the address of the next node. That means this is connected. That means after 1, the next element, next data element is 2. Okay, here you'll store the address of the next node, which is 300. Okay, that means these two are connected. The next field of the second node is pointing to the address of the next third node, and there are no more nodes. It's null. Okay, and head, you'll always store the address of the first node, which is 100. So what does that mean? Head is pointing to this. So your linked list will look like this. So even though you don't have continuous memory location, you manage to store this continuous values in like this using linked list. Okay, so that is what is the importance of linked list. So let's say, so if you want something like this, the next thing you wanted to go to next, and all, or back, next or back. So back, if that is needed, you need to use a doubly linked list, but we are not going to that. So let's say if you wanted to go next, and all, you can, whichever applications you wanted to do that, you can use internally a linked list to store that, to implement that. So let's say an image viewer, previous and next images are linked. So let's say one image you are watching, you'll be able to see next button, right? Next button will be there. So if you click on the next, we'll go to the next. So what is happening internally there? You store the path or the location of the next image search. So internally you are using a linked list. When you click on next, you're accessing the next node, the next image, next, like that. Okay. So image viewer, previous and next images are linked. Even though it is stored in somewhere else, you can link all those things, right? So like we have seen in the whiteboard. So image viewer, previous and next images are linked, hence can be accessed by next and previous button. So internally you can use a linked list in that application. So wherever you have that, let's say in the browser, you have a previous and next button. So we can access previous and next URL, the URL you accessed before, clicking on the back button. So by pressing back and next button, okay, so they are linked as linked list internally. They are implemented using a linked list. Same in the case of music player. Okay, we'll go to the next music, next, back. So songs in a music player are linked to previous and next songs. Okay, so songs may not be stored in the same like continuous location or something. Wherever it's stored, you can link. You can go to that when you press on the next button. So next and previous, then the node will look like this. This will be the data value. This is the previous. This is the next. Okay. That is called as a doubly linked list. So we are not going to do that. So let's say this will point here also. You'll have the data value. You will have a previous pointer and a next previous field and a next field. So if you click on this, you can go this previous, you can go this, but that is called as a doubly linked list. So we are going to see now singly linked list, the basic linked list. So we are going to right now, we'll go and implement a linked list in Python programming language. So we'll see how to create a linked list. The operations on linked list are, you need to insert a node, okay, wherever you want. You can insert it at the end. You can insert it at the beginning of the linked list. You can insert it at in between of the nodes, okay. So insert a new node at a position in the linked list and delete a node from a position in the linked list. So you can delete a node from the first, you can delete a node from the last, you can delete a node from in between. Okay. So those things you can do. So we'll see the logic and the code. So let's go back to the code. Okay. So I'll explain you the code. Before that, we'll just try executing this program. Okay. So I'm using Jupyter Notebook. You can use any Python code editor, Visual Studio Code, Jupyter Node, or you can use an online Python interpreter, whatever. So let's say I'm going to run this program. Inside linked list init method, I'm just giving a print. So we have many options, 1, 2, 5, append node. So let's say right now I'm executing it the very first time. So append node, display linked list, insert node at a position, delete node from a position, exit. We have these many options. Okay. So let's say I'm trying to display the linked list. Is that created? Not created. Linked list is empty. There are no nodes added. Okay. So let's create the linked list. So you can use append node. Append means adding at the end. Right now, linked list is empty. There are no nodes in the linked list. So you're going to append. You're going to add your first node. Okay. So I'm selecting the append node option 1. Enter the data value. Let's say 100, 200, 300, like that I'm going to store. Enter the data value. It went inside the add node method. So let's say display linked list. Linked list 100. The node 100 is added to the linked list. So I'm adding one more node, like appending one more node. Option 1, append node. 200. Okay. Option 1, the data value 300. Okay. Again, append node 400. Again, append node. Option 1, 500. So let's say let's display the linked list. Option 2. Sorry, this. Okay. So when you display the linked list option 2, it is empty. Now we are going to append our first node 100, second node, sorry, append node option. Second node data value is 200. Okay. One more node I'm going to append. The data value is 300. Okay. Let's display the linked list option 2. The linked list is 100, 200, 300. Okay. Now let's insert node at a position. So we are going to select option 3. Enter the position or index you want to insert the new node. So let's say this is our linked list 100, 200, 300. So the position is in this program I have taken like 0th node, first node, second node. Okay. 0, 1, 2. Which position you wanted to insert the new node? Let's say we'll insert at the last. So 0, 1, 2, third index, third position, you want to insert a new node. 0, 1, 2. So you give 3. Under the data value, I'm giving 400. Okay. 400. So let's display the linked list and see. 400 is inserted at the third position. 0th position, first position, second position, third position. The node added at the end. Let's add one node at the beginning, like insert the node at a position. So beginning means 0th position. So yeah, option 3, insert node at a position. So let's say I'm giving position is equal to 3. Sorry, position is equal to 0. So right now, 0th position is 100, 1, 2, 3. These values are there. So I wanted to insert a new node at position 0. So where it will come? It will come at the 0th position. Okay, and 100 should move towards right. So 0th position, right? I'm going to insert a new node. Let's say the data value is 50. Okay. So let's display the linked list. So where linked list was looking like this. Was looking like this. So right now I've inserted 50 at position 0. Display linked list. 50 got inserted at the position 0. Now 100 is at position 1, position 2, position 3, position 4. So insert node, you have inserted at the beginning, inserted at the end. Now let's try to insert at the like middle, in between. Okay, so right now our linked list looks like this. So insert node at a position option 3, I'm taking again. Under the position or index, you want to insert the new node. So index 0, index 1, index 2, index 3. So let's say I wanted to insert a new node at index 3. 0, 1, 2, 3. Third index. As third index, third position. Want to insert a new node. So position is 3. Data value 0, 1, 2, 3. So after 200, I want in between 200 and 300, I wanted to insert my new node. 0, 1, 2 as third node. I want 250. 250. Enter. Okay. Let's display the linked list and see. 50, 100, 200. Between 200 and 300, 250 got inserted. Right? So we inserted. Insert operation in the linked list is over. So let's delete a node from a position. So option 4. Under the position or index of the node, you want to delete. So let's say this is our linked list. So let's say I want to delete 300. Okay, what is the position? 0, 1, 2, 3, 4. I want to delete 300. So the position of the node 300 is 4. Okay. Let's display the linked list. 300 is deleted, right? So your linked list was like this. So now 300 is deleted. 200, 250, 400. So we have deleted a node from middle, like in between. Now let's delete the first node. What is the first node? Which is the first node? 50. Okay. So again, option 4, delete node from a position. The position 0. 0th position 50. I wanted to delete. Enter. Display the linked list option 2. 50 got deleted. Okay, now 100, 200, 250, 400. Now let's delete a node from the last, like let's delete 400. So option 4, delete node from my position. 0, right now your linked list is like this. So 0, 1, 2, 3. I want to delete the node at the third position. So position is 3. Okay, let's display the linked list. Option 2. $400 got deleted. Now linked list is 100, 200, 250. Okay, now I can exit. I have tried everything. Okay. So let's go to the code and the logic. Okay, for creating a linked list. So let's say we cannot use list and all to implement linked list in Python. Okay, so they use continuous memory location thing, right? So whenever you're creating an object of a class, okay, you're creating another object of a class. You know the class concept and the object concept in Python. So whenever you're creating an object, that object, you're creating an object of a class that is created in some memory location, creating next object of that class. Okay, that is not created in a continuous memory location of the previous object, is created somewhere else. So you want that, right? So each node will be an object. Okay, the implementation, each node will be an object, and you have to like link those nodes, link those node objects. Okay, so you need to use class to implement linked list in Python. So let's see how do we do that. So let's start from here. Say you can do it in different ways. So we'll see one way of doing it. So class linked list. Okay. So we have an init function, where we initialize the, so linked list class, the init method. What are you doing? Just a print statement inside linked list. So you define the class linked list. It has init method. You define the init method. What are you doing? The linked list, just define your head. The linked list, this head, and you're assigning none to it. Okay. So what will happen? You're doing like this. Okay. So how it is? There is a variable none. Sorry, a variable head. Okay. Variable head. Head is none. Right now, head is none. Okay, and you have defined the functions append node, display, insert node, delete node function. So let's start from here, the main, and you have one more class. So we have the linked list class. There you initialize the head variable as none at first. No nodes are there. So you defined all the methods append node, display linked list, insert node at a position, delete node inside the linked list class. Okay, let it be. You have one more class node, to represent every node. Every node object will be object of this class. What is there in that? So this you don't need to do actually. So you can use a temporary variable inside. So let's say this is not there. So what you want inside a node, what all things are there in a node of a linked list? Data and next field. Okay. So you are defining self.data, self.next. So these two things are there. These two variables are there. Fields are there in a node object. Data field, next field. So let's start from here. You have the menu. Okay. You have created the linked list object, linked list class. You have created the linked list object. So you have created the linked list. When you're creating an object of a class, so you have created the linked list. The init method will get called by default. So we go here, linked list, init method got called, your self.head, like the instance variable, link underscore list instance variable got initialized to none, that we have seen. Okay, that happened. Now choice, yeah, choice equal to none. We are printing these options. You want to enter your choice. So right now the linked list is, so choice not equal to none. What is choice? You entered something 1 2 3 4 5. So inside a while loop, choice not equal to none. Yes, choice has something. Let's see if choice is equal to 1. So what is 1? Append node. So let's say if you are trying to display the linked list, first display. We try to display the linked list first, right? So right now there are no nodes. So what will happen? Choice equal to 1. 1 is append node. Choice equal to 2. 2 is display linked list. 3 is insert node. 4 is delete node. 5 is exit node. So those things we call the linked list dot these functions from the class. Okay, so let's say if you try to display the linked list at first. So you created the object linked list dot head is none. Okay, so if you enter the choice display, choice 2, you're calling the, you created the linked list, right? Linked list object of the linked list class, link underscore list dot display. You will call the display function. It will go to the display function, this display function. Self means what? The current object is passed. Current object is what? The link underscore list, the linked list object. So it goes to display. So you created the object, that time head is none. So you're checking if self dot self means that linked list object. Okay, where you are calling the display function linked list dot display. So this object is the current object, linked list is passed to self. So self means linked list, your current object. If linked list dot head not equal to none, it will go here. So right now it is none, right? So it will not go here inside if, okay, it will go to this else and print linked list is empty. So that's what we got here when we try to display before adding any nodes, you'll get linked list is none. So let's say you selected the option append node again. Append node, right now if you select append node, you're going to add the very first node. Okay, what will happen then? Choice is equal to 1. So you want the user to enter the data field, the node value. So you ask the user, you take that input into data. And what are you doing here? You're creating the node. Okay. You're creating the object of the node class. You're creating the object of the node class. What is the node object's name? Node. Small letter node is equal to node of data. So what are you doing here? You're creating the object of the node class. That means you're creating the very first node of the linked list and passing the data value. So what will happen? The init method of the node class will get called. Init method of the node class will get called. So what is passed to node? Self node, your current object. So node.data is equal to data. The data value you entered will be stored in the data field of this object, data. And right now, node.next is equal to none. Okay, so this much happened. Head is none. So you created a node object. Okay, when you creating a node object, so this is node object, name is node. Okay, what are you doing? You passed, let's say you entered the value 10, created dot data, node dot data is equal to 10 and node dot next is equal to none. Okay, node dot next is equal to none and head is equal to node. So head is equal to node. Node means you give node, it will take the, let's say, memory address of the node, the reference. So it was none, the head was none. Okay. Now you append node function, what you will do, you will store, let's say this is 1000 address. You store this. So what will happen? This is pointing to this. So you added the very first node in the linked list. Okay, you added the very first node in the linked list node. Let's say the address is 1000. So this much happened. Okay. Node dot data is equal to data. The value you passed, node dot next is equal to none as of now. So you added one node. Okay, let's say if you're clicking on the append node again. So what will happen? It will again call the append node function. Okay. Append node function. So it will call the, so when you create the object, this much happened, you created the node. So when you call the append node method passing that data. So let's see the append node, self node. You created the node dot data is 10, node dot next is equal to none. So append node or add node, whatever, append node method you went inside. So you're checking. So let's say we are checking head is equal to none. So this happens. So I told that head is right now at first head will be none. You created the node, but you didn't connect that. You didn't store that to none. So if head is equal to none, you are going to insert. Yeah, the node is the very first node. So you store that node's address in head. Okay, because head was none, no nodes were there at the starting. So this is going to be the first node. So self dot head is equal to node and So you don't need to use this temp as self.temp. So let's say you start a temporary variable. There you store the address of the node also. Node as well. So let's say this much happened. Okay. So head was none before, head was none. You stored that address. So this is connected. So similarly, what will happen if you do next? You create a append node method. If you call append node method, what will happen? You'll create the node. You ask the user to enter the data value. Let's say it is 20. You'll make this as none. Okay. Now we made the temp pointing here first. So temp is equal to node, right? So your temp is pointing to the first node as well as head is also pointing to the first node. Okay. So what you'll do, you created the node and you call the append node method passing this node or the data value passing this. So you created the node, you call the append node methods. So right now temp is pointing to here, head is pointing to the first node, your node is there, it's not connected. So what you'll do basically, you do temp.next is equal to node. So this temps next, okay, you'll store the data value, store the address of this newly created node. Let's say the address is 2000. Okay, temp.next is equal to 2000. So what happened? This is linked. Okay, then you move this temp to here. So how do you do that? Temp is equal to temp.next. What is temp.next now? Temp is equal to temp.next. Temp is equal to temp.next is 2000, right? Temp.data is 10, temp.next is 2000. Temp is equal to 2000. So what will happen? Temp is no more pointing. If temp contains 2000, then where temp is pointing? Temp is pointing to the node where the address is 2000. So temp, you are storing 2000, like temp is equal to temp next, that code statement executed, then it will become like this. Okay, so when you're appending your next node, you create the node object, you enter your data value, you'll store the data value here, you'll keep this field as none. Okay, now what you'll do again, just two statements, temp.next, okay, is equal to node. So node, let's say node then 3000. So here it will become 3000. So that means what? This is connected. This is connected. Now temp.next is 3000. Okay, temp.next is equal to node. That statement will do the linking. Okay, now you'll move your temp. Temp is equal to temp.next. Temp is equal to temp.next. So that implies temp is equal to, what is there in temp.next? 3000, right? So temp is equal to 3000. The moment temp is changing to 3000, what will happen? It's no more pointing to here. It is pointing to here. So like that, that is the logic behind the append node. You append every node. So append node, see, it is the very first node, you will add that address to. So temp.next is equal to node, temp is equal to temp.next. So as it is class instance variable, you're using self.temp.next is equal to node. Self.temp is equal to self.temp.next. Now, if you're inserting a new node, what will happen? Let's see the logical and see the code, insert and delete. If you're going to insert a new node, let's say append node will happen like that. Next, next, next. Your temp will be always pointing to the last node. Okay. You create a node and the last node's next will be null. There you store the address of the newly created node and you move your temp to the last node, newly created node. So those two statements, these two statements will do append the node at the end. So let's say if you wanted to insert, so the same logic append node will work if you are inserting at the position, let's say 0, 1, 2. If you want to insert the position, insert at third position, that means at the end you want to add your new node, same logic only will work because you will have your temp at the last, right? So let's see insert node, let's say insert node at a position. So what you will do? So choice 1, append node is over. So let's see these two, insert node at a position. Choice 3 is insert node at a position. So you will ask the position from the user, you'll ask the data value to be added in that node. You create the node object. You create the object of the node class. So what will happen? It will call the init function of this node class, and your node's data will be the entered data passed here. Okay, and the next field will be none. So you created the node. Okay, you created the node, that node you wanted to insert. So you'll call the linked list.insert node method, passing the newly created node with the data value, the entered data value, and the next field as none. And you'll pass the position also. You wanted to insert this node at this position. You pass this linked list.insert node. You wanted to insert this node at this linked list. Okay, the new node is this node at this position of this linked list. Okay, so this linked list is passed to self. Insert node method will be called. You'll go to insert node method. Self is what? The current object, linked list. Node, the newly created node. Position, the entered position. So let's see. So if position is like the end, it will happen as it is. So here also, what you'll do, the logic. Okay, let's say we created the linked list. Okay, we created the linked list. You have the head. So let's say the address is something like this. One, two, three. Okay, here you will store the address of the next field. Here you will store the address of the next field. So this is linked. This is linked. There are no more nodes. So head, you will always store the address of the first node. So this is linked. Okay, there are no more nodes here. So let's say this is 0, 0th node, first node, second node. So let's say I want to insert a new node at the middle. So in between 0 and 1 at the position 1. So your position is what? Your position is equal to 1. You want to insert a new node in the middle. So you'll create the node you want to insert. So let's say right now your temp is here, but okay, position is 1. So you'll create the node. Okay, let's say you created the node. Okay, you created the node. You want to insert 1.5 in between 1 and 2. This is none. Okay, so this is your node object. Created the node. You ask the user to enter the data value. None. Next field is none at first. So we need to move that. We'll use a while loop and move this head. So we'll take a pointer variable, just one variable. We'll store head into that. So let's say we'll move. So here you don't need to move. So position is 1, position minus 1 is the next node. So your pointer, the logic of insertion, where you want to insert your pointer, you make your pointer pointing to the previous node. Okay, so when your position is 0, position is 1, your pointer should point at the position 0. So let's say if we take p is equal to head. Okay, is equal to head. So if you want to insert here, so position 0, first node itself is the previous node. Or if you want to insert somewhere here, you will move your pointer till here. Okay, so right now your p is equal to head, then p is pointing to here. P is equal to head means what? P also stores the same address. So H. So the P also stores 100. Okay. P stores 100 means P is also pointing here. So you make the pointer point to the previous node, after which you want to insert your new node. That is the first thing you do. Now what you will do to make this connection? Okay. You need a temporary variable. Okay. So you will store this 200 if you are going to change this position. So what you actually needs to do, let's say this address is 3000, this new node's address. You want to store 3000 here, then this is connected. And this part you want to store 200, then this is connected and this node is inserted. Okay, that's how you do. So using the programming language. So right now we have P. So we are going to replace this value. So you need to take this 200 address into, so temp is equal to P. So P is what? P is 200. Okay. Now you are going to change P. So how do we do this? Like P is pointing to the first node only, right? We have taken this value. We are going to replace that value. So P dot next is equal to node. P dot next is equal to node. So node's address. P dot data is 1. P is pointing to here. P dot next was 200. You have taken that P dot next value 200 to a temporary variable temp. Okay. Now you can replace this. So P dot next is equal to node. What is node? Node's address is 3000. So what happened? This is connected. Now this link is not there. Okay. If it is storing 3000, it will store to a point to the location of the newly created node because that address is 3000. We'll insert. So this connection happened. Now you want this. Okay. So this is what? Node. You know that node. So nodes next, node dot next. Node dot next is null. None now. Node dot next, what you want to store? You want to store this 200 address. Where is the 200? You have taken it into temp, right? So node dot next is equal to temp. That means node dot next is equal to 200. So node dot next was none. You will store 200 there. So if you store 200 there, that means it will point to here. Okay. So you have successfully inserted a node at the beginning. Sorry, not in between the linked list. So this is the logic. So first you need to make the pointer using a while loop. Okay, position is 1, position -1. You'll make the pointer pointing to the previous node, after which you want to insert your new node. Then this logic. You take out this, replace it to the first node's newly created node's address, and the newly created node's next, you need to store this. So this address you have saved, that address only you need to save here. So this connection happened, and your node is inserted in between. Okay. So yeah, so that's what insert node we have written. Previous position, you need to take position -1. Let's say our position is 1, previous position is 0. If position is equal to 0, you need to, what does that mean? You are going to insert your new node as the first node. You want to insert at the beginning. So insert at the beginning, what you will do? You'll just check head is none. If head is none, then there are no nodes. The node you are going to insert at position 0 is the first node. So you will store that node's address in head only. Okay. If head is not none, what you will do? What you will do? Okay. So let's say we have a linked list already. You're going to insert a node at the beginning. Okay. Your head is like this. The head is pointing here. These are the nodes. Okay. 1, 2, 3. Okay. You store 200 here. You store 300 here. This is none. So you want to insert a node at the beginning. So first of all, you'll create your node object. So let's say 1.5, sorry, let's say 0, and this is none. So this address is, let's say 50. So what you'll do, you check node is head is none, no head is not none. So what you'll do, you take a temporary variable, temp is equal to head. So 100 you saved in the head. So head you need to change, because then what you will do, head is equal to node. Okay, head is equal to node. If you do, what will happen? Head is storing. So this is gone. So head is not 100, head is now 50. So 50 is the address of this first node. So this is the first node. This connection has gone. Okay. Now the next node should be, the next was none, right? So what you will do? So you taken that 100 address here. So temp, sorry, node, this is node dot next is equal to temp. So temp is what? 100. So node dot next is equal to 100. Then this is pointing to here. So which is the first node now? This node, 0th node, first node, second node, third node. So you successfully inserted first node at the beginning, and end same append logic. And in between we have seen that. Yeah, insert node. So you point your you take a pointer, point that to the previous node, and insert in middle. So insert at the end, that position, that is the same logic as append node. Now one more, then we'll wind up. Delete nodes. Okay, delete node. So if you are clear with the logic, it's not that difficult to write the code. So again, we have our linked list. Okay, this is head. Now we are going to do the delete operation. Okay, let's say head is equal to 100, means head is pointing to the first node. Okay, data value, let's say 1, 2, 3. Next field, you store 200 here, so it is pointing here. You store 300 here. The reference in Python doesn't have pointers. So last node is, last node's next is none. So this is the data field. This is the next field. Okay, so you want to delete a node from first. Okay, you'll give position as 0. So what you will do? Okay, you'll point P is equal to head. Okay, so P will be pointing here. Okay, P is also pointing here. So let's take a temporary variable. Okay, store, you want to insert the node at position 0, right? So temp is equal to P, temporary variable, you store this address. So you'll create your node. Okay, create your node, let's say 0. This is none. So what you will do, head is equal to, let's say this address is 2000. So you'll change head is equal to 2000. So head is equal to 2000. If you change, what will happen? This link is not there. Okay, head is pointing to here. That means head, this is the first node. Now you want to link, this is the second node now. So this is 0. So here it is none. So what is that? Next field, nodes next field, node dot next. Node dot next is equal to temp. We have taken this, right? Node dot next is equal to temp means node dot next is equal to 100. So it is pointing to here. So you inserted successfully a node at the starting, 0, 1, 2, 3. Now the position is like this. Okay, so that's the logic to do insert a node at the beginning, insert a node at the, delete, delete a node from the beginning, right? So I was telling delete method. So what's the logic to, let's say, the logic to delete in between? Okay, so delete also, you wanted to take a pointer. So if you want to delete the first node, what you will do? Same, P also you make pointing to the first node. Then, okay, let's take the temporary variable. What you will take? P dot next. What is P dot next? P dot data is 1. P dot next is 200. You have taken 200 to a temporary variable. Okay, now you want to delete this. So what you will do? Head is equal to temp. Okay, head is equal to temp, then head is equal to 200. Then head is pointing to here. Okay, then you delete temp. Delete temp. Temp means this. Temp is equal to, delete P. So you delete P, what will happen? This whole node is deleted. Node is deleted. So the first node is deleted. So let's say you wanted to delete a node in between. What you'll do, let's say this is 1, this is 100. This is 100, this is 200, and this is linked. A linked list is like this. You want to delete, so this is the 0th node, first node, second node. So you want to delete the node 1, the middle node, the node in between. Okay. So what's the logic? So there also you need to take a pointer using a while loop. You need to make that pointer to the previous node. You want to delete this node, then you make your pointer pointing here, the previous node, wherever it is. So here it is first, the 0th node itself. That's it. So you make it point like this. Okay. Then what you'll do, you want to delete this node, right? So what you will do, basically this node should not point here. This node you're going to delete. This node should point to this node, right? Okay. So let's take a temporary variable. You wanted to get this 300 address, right? Where is 300 stored? Here. Let's say your P is here. Okay. P dot next. What is P dot next? P dot next is 200. That means this node. P dot next means this node. Okay. P dot next. Dot next. What is that? P dot next 300. Okay. Temp is equal to P dot dex not next. That implies you're storing the value 300 into temp. Okay. So now temp is 300. Now what you'll do? Okay. And you can store the okay, you have taken this value. You can store this, delete the node you want to delete is which one? The next node of P dot next. So P dot next is what? 200. Okay. So this is 10. So what you'll do now? P is equal to temp. Sorry, P dot next is equal to temp. P dot next, you're going to change it as temp. So what is temp? 300. So what happened? Connection is like this now. Okay, this connection is not there. Now where it is there, D, the 200 is stored in D. So you'll do delete D. Delete this node. So this node is deleted. If that node is deleted and the connection made like this, so what happened? This connection is also not there. The node in the middle, got deleted, right? So that's the logic. So point whichever node you wanted to delete, take a pointer, move that to the previous node, then do this thing. Then your node is deleted at that particular position. So if you want to delete the last node, that's more easy, right? That is more easy. You have to take a pointer. You want to move that, or there also you can take the position. The position you will be giving the position, right? So let's say here the position is 1. So you're going to delete the last node. So you can take your pointer pointing to the previous node. Okay. Then what you'll do? You delete the p dot next. P dot next is what? 300. You delete 300. Then you delete 300. Then this node is gone. Okay. Then when you store p dot next is none. P dot next as none. Because you deleted the last node, then this node is going to be the last node. So you deleted the last node. The previous node is going to be the last node. So that's what you do when you delete from the end. We have taken more time, but yeah, so it is like this. So delete node also, you take a pointer, is a while loop, make that pointer to the previous node of the node which you wanted to delete, then do this operation. Okay. So D is equal to P dot next. The previous node's next node, that's what you wanted to delete, right? Okay, then that node's next should be none. Then so all the logic is like this. So yeah, so that's it. The linked list operations. So let's go back to the. So we have seen like how to create a linked list, how to insert a new node at a specific position in a linked list, how to delete a node from a specific position, either from the starting, either or end or middle. Insert, either delete from start, end or middle. So I'll share the material in the Discord channel. Sorry, the Discord Nestria channel. Okay. So all of you can please join, click on this link. So this link to install Discord and to join the Nestria server in Discord, link is shared in the description of this video. I'll be shared in the chat also. So my name is Indira. So you can connect with me in Discord. Once you install Discord, this is my Discord ID. So thank you all for joining. I'll just show you. So once you install Discord, you will get like this. Okay. So when you click on the link to join Nestria, so this is the Nestria. So you'll be part of this Nestria community. So on the left panel, you'll be able to see this. So click on this join a topic. So we have this is a community. So we have many channels, many groups on the Discord Nestria server. So the respective group, whichever is you are interested in, you can join. So we have a Python group, JavaScript, blockchain. So if you click on this particular symbol below, whichever group you wanted to join, you will be part of that community and you'll be able to see this in the left panel. Okay. So this material of this webinar, I'll be sharing in the Python resources channel in the Nestria Discord. Okay, so I'll be sharing here. If you want to connect with me directly, use this Discord ID. Thanks all for joining. So don't forget to subscribe us, Byte Academy on YouTube. We'll go live every Monday and Friday at 3 p.m. IST. So Mondays will be career related webinars and Fridays will be tech talks. Thank you all. Bye. Happy weekend.